that would fill that space.
Okay, and thank you. My second question is about the microscopic Higgs physics. So before the electroweak symmetry is broken, well, I mean, above this energy scale, the Higgs basically is a doublet. So there are 4 degrees of freedom, and the doublet, each one is a complex scalar field. And I wonder, how does this picture of Higgs fit into your large-scale scalar model?
I think that remains to be investigated.
Right.
The connection between particle physics on that level and this remains to be investigated.
Okay.
And also, once one go into that, there will be other Higgs fields from supersymmetry.
Okay.
So that the universe might be filled with different kinds of superfluids, more complicated.
Okay.
From Higgs and also super Higgs and whatever.
Right. And actually, there is a question related to this. So we know that the phase transition between a normal fluid and superfluid, there is a global U1 which is broken, and so the order parameter for the superfluid is already responsible for the breaking of the global U1.
Right.
And according to your model, it seems that in the microscopic scale, this scalar field is also responsible for the electroweak symmetry breaking.
Yes.
But we know that electroweak U1 is electroweak SU2 is basically a gauge symmetry, which is local and is different from the global U1 symmetry. So these two kinds of symmetry are different, and I wonder, how can a single scalar field break both?
Well, the Higgs field that I mentioned breaks local gauge symmetry.
I mean, breaking of a symmetry will develop order, and order is a scalar number, right? So how can a field carries several scalar numbers?
Well, that's the same. That's the same question as in a standard model. There's no different standard model. We introduce a Higgs field to break the symmetry, which is local gauge symmetry, and that presumably happens below some temperature. And that temperature is very high. We assume that it's always there. That at 10 to the minus 30th second after the Big Bang, we're already below the temperature.
Okay, if there's no further question, let's thank Professor Huang again for a very nice talk.